Good morning once again. My name is Edward Wasrum. We are going to be doing something different from what we did previously this morning. We are going to do summary statistics, or what is generally known as descriptive statistics in research work. Recall that in my previous classes I told you that in your thesis work or your research work, after descriptive statistics or what is called the basic background, you are going to do empirical estimations. But inherent in the basic background is what we call the descriptive statistics or the summary statistics. That means that a summary statistics is also known as a descriptive statistics. And this statistics, it describes the characteristics of the time series data in terms of its mean value, its median value, the maximum and the minimum value, the skewness, the cortices, the Jacobi statistics and its probability value, and also the mean sum of square. But basically, these statisticals enables the researcher to know the real characteristics of the data estimates that is being used or that will be used in the research work. And we are going to do a minor interpretation of all the items listed previously. But before we interpret them, we are going to estimate or to generate a summary statistics using the EView, and the process required for generating a summary statistics using the EView includes: one, to load the time series data into the EView worksheet, which I have taught in my previous video. Then once the time series data is being loaded and the EView worksheet displays in your screen, the next thing you will do is to go to quick. Once you click quick, it moves to group statistics. Once you move to group statistics, you click common samples or individual samples. Then the input button or portal will pop up. You input the variable names into the inquiry block, starting with the dependent variable or dependent variables. Then without changing anything, you click OK. Once you click OK, you are going to get your descriptive statistics. Let me show you what I am talking about. Let me show you what I'm talking about. Like this is my EView worksheet. This is my EView worksheet. This is the EView worksheet. If my data is being loaded like this, and you want to generate a summary statistics, which is also called a descriptive statistics, the first thing you are expected to do is to click on quick. Once you click on quick, you will see these drop downs. Then you go to group statistics. Once you come to group statistics, you maneuver to descriptive statistics. Once you move to descriptive statistics, you now pull over to individual samples. If you click this individual sample once, this box will open, erase what is in it. Remember I said that you will start with the dependent variable, and let's assume that we are working on the effect of deficit budgets on economic growth in Nigeria, and our dependent variable is GDPPC with the GDP per capita. What I will now do is to type in cap log GDPPC. I'll move on, I'll give a space, and now type in BGD, I'll give a space. I observe that we have export and import in this data. I also type them in. I give a space. I also type import. I give a space. Then we have interest rates as a moderating variable. I will also have Okay, we have interest rate and exchange rate rather, as we discussed. Okay, but one thing is normal here in this descriptive statistics, like graph. These variables are being typed in their normal characteristics without being logged. While conducting descriptive statistics and graph, it is actually expected that you don't log loggable item. You allow the variables to be in their natural raw form, so that you get the true behavior of the time series data you are working on, because it is the outcome of the descriptive statistics that will prepare you, or that will advise you, or that will make you to also proceed with other forms of estimations. So basically, if you didn't get the descriptive statistics right, it will be very, very difficult for you to proceed to do other things. So allow them in their raw form and proceed. Once you're able to type in the items in this form, separating them with a space, not a comma, without a C, if you click OK, you are going to, oh, my estimation was, so you get something that looks like this as your descriptive statistics. So what you will now do is to copy it neatly to a Word document for interpretation. I'm copying it, I've highlighted, I've copied as displayed. Okay, then I'm moving it to the Word document for interpretation. This is my Word document. I'm moving it to this place for interpretation. Okay, this is my Word document. Is okay now, I'm good for interpretation. So basically, this is my descriptive statistics or summary statistics. So what I will now do is to offer interpretation to the mean, the median, each of these items. I was supposed to interpret them one after the other, one after the other, one after the other, one after the other. So basically, if I should also explain further from the notes we have here, I want to explain to you what the mean means. A mean is defined as the mathematical average of set of two or more data values which you know from your elementary statistics. The median is the middle number in a sorted. The median is the middle number, is always sorted in ascending or descending order. Then the maximum and the minimum value, we all know what they means. Then the kurtosis and the Jacobi-Beira and the skewness. Basically, we have to interpret this particular descriptive statistics. The mean value for economic growth is 1803.488, while the median value is 1607.00. And critically, if you look at the mean is far from the median, and whenever time the mean or the median disperses from the mean, it then means that the variable in concern do not have what it takes to withstand the standard aggression in the long run. That means that GDP-PC is fragile to sustain stability in Nigeria over the long period of time. That is the meaning of the disparity between the median and the mean. Then the maximum value is 2564, while the minimum value is 1324. That means that the maximum is very higher than the minimum, which is also a good one. The standard deviation of 453, but the skewness is 0.456742, and this skewness value is positive, and it connotes that the dependent variable GDP-PC has a positive skewness and has a long right tails. And given that it has a positive skewness and it has a long right tail, it's desirable for normality. But let's proceed. Look at the kurtosis, which measures the peakedness of the distribution. The kurtosis value is 1.556985, and this implies that the GDPPC has a pleitochotic dimensions, which is relative to normal distribution. That means that the normal distribution is not adhered in PPC variable, and I'm not happy with that. But we are going to look at Jacobera again. The Jacobera statistics of 4.98 has a probability value of 8%. That means that the Jacobera and the skewness are saying the same thing, while the cortices is saying a different thing. Okay, given the fact that the Jacobera statistics is telling us that there is a normal distribution in the series, we are going to accept that there is a normal distribution in the series. Then basically other variables like budget deficit has a probability value that is less than 5%. In this context, it means that there is no normal distribution in this context. There is no normal distribution in this context. Then external debt is also showing us that there is no normal distribution in external debt. Internal debt is saying the same thing, that there is no normal distribution in the internal debt, while interest rates and exchange rates are confirming what the dependent variable has said in the first place. That means that in this particular summary results, the behavior or the characteristics of the time series data are not homogeneous. While the dependent variable GDPPC, interest rates, and external debt are telling us that there is a normal distribution irrespective of the value of the cortices. Then budget deficit, external debt, and internal debt are telling us that there is no normal distribution irrespective of their cortices value. So given these complications, we are now expected to perform further analytical estimations to enable us stabilize this relationship and make uniform inferences as a result of this. So basically, this is the major reason why after conducting a descriptive statistics, is fine researchers proceeding to perform other forms of estimation. Had it been that all these variables follows normal distribution, then there would have been no need to proceed to other means of estimation. Researchers can just use only the descriptive statistics, make inferences, make conclusions, summarize their work, and have them published. So my brothers and sisters, readers, this is how you do descriptive statistics. The interpretation of these values are not rocket sciences, or rather they are being interpreted according to what I have said before. If you look at what I wrote down here, the Jacobera text is a goodness of fit test of whether samples data have the skewness and the cortices matching a normal distribution. The test is named after Carlos Jacque and Anneke Bera in 1980. The test p-value reflects the probability of accepting the null hypothesis. If it's too low, then you reject it. You must set the confidence interval, for instance, 5%, then reject the null hypothesis. So that is all for Jacque-Bera statistics. So cortices is a statistical measure that defines how heavily the tails of distribution differ from the tails of a normal distribution. A cortices in a summary statistics is used to measure whether the distribution is too peaked or not. A peak series is that which has a normal distribution with most of the response in the center. Cortices help to show how the tails of the distribution differ from the tails of an assumed normal distribution. And cortices can be positive or negative. A positive value tells you that you have a heavy tails, while a negative value tells you that you have a light tail. So basically that is how courses are being interpreted. Then skewness indicates the direction and relative magnitude of distribution deviation from the normal distribution, and measure of symmetry of the distribution. In an asymmetric distribution, a negative skewness indicates that the tails on the left side is longer than on the right side, and conversely, a positive skewness indicates the tails on the right side is longer than on the left side. So actually, this is how we interpret descriptive statistics or summary statistics. In summary, again, what we have learned so far in this particular class, that summary statistics is the same thing like descriptive statistics. It helps you to actually ascertain the characteristics of this time series data you are working with. So basically, if you have it estimated like this, and whenever time you are having a consensus, a situation where the normality condition of the time series data, they are not in line with the Gaussian condition, that means that the researcher will proceed to estimate, to ascertain their behavioral disposition through other sophisticated means of estimation. Thank you for staying tuned. Thank you for being with us. Thank you for being on my channel. I pray that you keep tuned with us. We are going to expose everything that is required for you to be able to have applied econometrics in your fingertip. Always subscribe, like our page, and recommend to your friends and colleagues. Thank you and God bless you. I remain your chief servant.